Welcome, everybody. Hey. Oh, shoot. When it starts with an applause, it's like, it's just going to go downhill from here. So as long as your expectations are low, we'll have a good time. All right. So welcome. So my name is Rydalch. I work on the Solaris team, trying to help make Solaris and USD more fun, more better. So today, my talk is called Composing Materials in USD and Solaris. And we're going to talk about the mechanics of materials and shading in USD, not so much about making cool looking assets and art, more about these building blocks and how to leverage what USD provides and what Solaris provides for material workflows. So it may get a little technical or more technical than if you were an artist that just wants to make cool art. But even if you're an artist and not a TD, I hope that you'll get a little bit out of this that helps you debug, just like with Mark's awesome talk that we just listened to about cooking. Hopefully it'll help you to understand a little bit more what's going on. The two big questions that I hope we will answer by the end of our time is, how does shading work in USD, and how can I use composition to make my life better? The third, I guess there is kind of a third question is, why isn't it easier or faster or better? So that third question, you'll hear throughout, or we'll talk about things that are maybe you have to do manually or you have to set up. Kind of anything that looks like a stumbling block or a sharp edge is something that we're working on to improve the UX in Solaris. So even if I don't explicitly say it, there's a lot of things that we're aware we're working on, some of which take a little bit more time to lay the groundwork underneath to let us to do awesome stuff in the future. So, all right, what does shading in USD look like? So we're just going to look at these three primitives. These kind of form the basis of materials in USD. So the first is appropriately enough, the material. The material in primitive is a render agnostic container in USD. It will be full of shaders. And if you've messed around with it, maybe this seems like obvious, but we'll just review these concepts. So it's this container that has shaders and node graphs, which we'll talk about in a second. It's got outputs. These outputs are namespaced for renderers or render context or shading targets. You'll see that all those words thrown around in USD literature. The contents of materials are shaders. This is the meat and potatoes. This is 99% of what goes into a material. Ironically enough, when we get heavy scenes from customers, it's not unusual that 60, 70, 80, 90% of the prims in the scene are shader prims, especially if you've taken HDAs and wrapped up hundreds of VOP nodes, which get translated into shade prims, and those exist many, many times in your scene. The prim count overall can be dominated by shaders. So shaders are unique because they are just one prim type, but they can have a different source. So there's three source modes, types in USD. There's ID, there is the asset path, the asset path, and then source code. So the asset path one, we don't have any examples of here, but we're going to look at ID and source code. Oops. So this Vex builder, if you started with Solaris early on and you were using just the regular principled shader, you would see a lot of these in your scene. And if we look at it, oops, hold on. Where did that? Oh, there we go. Sometimes the scene graph details gets crazy. So if you look at the source code, you can see it's literally source code. So that whole string just gets dumped in there. This could be some of the performance bottlenecks with material library, is when you're building these Vex shaders, which only work with Karma CPU, or you would use this as a transition from Mantra, most likely. But it's taking all those VOP nodes and putting the Vex code on the shade prim. So that's why its source is source code. Most of them, however, are going to be ID. So in this case, the ID is this Material X standard surface shader. Again, most of the time, these are going to be IDs. Does this matter so much? If you're debugging why something looks weird or some shader isn't working, this is probably not likely a problem coming out of Solaris, but maybe coming out of another package, or if you've got some scripts running over and doing stuff to convert shaders around. Maybe the ID has gotten messed up, but just wanted to point out what that shader, that attribute or characteristic of shaders. And then the third building block is the node graph. This is a container like materials, but it is a chunk of shading network, kind of like a subnetwork would be in VOPs. We're going to talk about why this is cool with USD and referencing in a little bit. But it really is just, again, a way to organize your material. So if we go back to our example material, there's a bunch of node graphs in here. In this case, they've been organized by the shading target, the render target. So we've got Karma, Material X, and just USD preview. So circling back to materials, I mentioned that they're render agnostic. So how does USD tell you, hey, this material has something for Karma or RenderMan or Material X? The outputs are namespaced. The default output, like what you get with preview surface, is just outputs : surface. But you'll notice there's outputs KMA surface and outputs Material X surface. There's even outputs Vex surface for classic ye old Vex. And what a renderer can do is it will ask, through Hydra, it'll say, give me your Material X surface, give me your Karma surface, give me this or that. And materials or renderers like Karma, they have an ordering. And this is in the Karma user guide that has an ordering of which surfaces it looks for first. Why is this powerful? If you need to add a new renderer specific language or description to a material, you can do that. So we don't have them here, but if you have RenderMan or Redshift or Arnold, you'll see those namespaced outputs as well. Now the materials they have, and we're gonna talk about some applications and examples of this, but materials can have inputs. And this is the public interface, is what they call it. These are also renderer agnostic inputs, and these can plug into any shader within the material. This is powerful because if you have, as an example, a simple base color, you can wire that into the standard surface on the Material X shader. You could wire it into the preview surface's base color. You could wire it into the Pixar, what is the Pixar layered material? I can't remember exactly what their canonical PBR surface is. You could do the Arnold, the Redshift one. They can all be driven by that same control if need be. So it's pretty powerful. Let's see. So we talked about shaders, node graphs, materials, and the outputs. All right. So the other half of this coin is getting the materials onto stuff, right? So here we have this little simple scene. We have a little shader ball, right? So how does Houdini GL or Houdini VK or Karma know what materials are on there? Material assignments. And the way you can inspect that in the scene graph tree, or excuse me, the scene graph tree and the scene graph details is by selecting a primitive. Now these purple attributes are computed values. So there is no attribute on the USD prim or in your scene that is the local transform or the computed purpose because it involves hierarchies and some heuristics. So USD will compute this for you. And if you haven't already seen it, there are these two really important ones, especially for our conversation today, about resolved materials. And this is because of some characteristics of material bindings. In this case, if you look at the shader ball, its resolved preview and full material is this lookdev material right here. If we go down the hierarchy and look at this geometry transform, it's still that lookdev material. Now, if we select this primitive here, this core face, the resolved material has changed because it has, in this case, the binding is on this primitive. And this material binding is a relationship. It's just relationships in USD can be, many things, right? They can have arrays of targets, but the material binding just has one. That's an array of one. And in this case, we've bound this neutral material that has a little graphic on there. So when you're wondering what materials there are in your scene, and you select prims and start looking at the scene graph details. So this is can be a useful debugging tool. And this color scheme, this convention is the same in USD View. Because I know sometimes in pipelines you just crack an open USD View to look at something before it goes into the pipeline or off to the farm. And the colors are well, our best copy of the ones from USD View, but they should be the same. But they behave the same. All right, any questions so far? Okay, so we've blasted through the basics and nobody left. That's a good sign. All right. My goal is not to make anybody leave, by the way, but I understand if you're like, gotta step out. Okay, so let's look at making materials and looking at some of the bindings. So the first contact in Solaris for making materials is material library. And this is this LOP node that inside has a VOP context. Yes?
I'm wondering, it's hard to see the bottom pane because over everybody's head.
Oh.
Can you swap the panes? If you're just putting time in that network header, then the parameters, can you swap it? So
like this?
Up? Yeah.
Yes, I can do that. Thank you for letting me know. Actually, and I worry that because we're going to be in both, so let me do this. All right, so we're going to get a little parameters pane over here. Maybe that's the best of both worlds. Sound good?
Yep.
Thank you for letting me know. All right, so in the material library, this is where we build our materials. Now, a release or two ago, our tab menu in here got really small. And at first it confused, it saddened, it surprised, a lot of emotions. But we did it for a reason, all in the name of UX, right? As long as those two letters are attached to any justification, it's a good one, right? Because the UX said so. So in here, we are only exposing this this is where we're trying to communicate the idea of materials. So we have these builders now, and they correspond to kind of your renderer targets. And we do this, A, to clean up the VOP menu because it's insanely long. B, to reduce footguns because it's really easy to put a regular add node in the Material X network and they don't work together. So problems would ensue and there would be tears and crying and gnashing of teeth and bug reports, and people would corner Mark Tucker, after meetings and be like, "What are you doing?" So for Mark Tucker's sanity, we did this. So when we put down a builder, and I'm just going to do a Karma material builder, it puts the subnet down that represents our material. And if we look, sorry, let me switch this so that it's high up. If we look in here, it's added that new material. Right now it has some default stuff in it because that's how we've configured it. But this material builder, it has some special attributes to it. And we're going to connect back to this later on because a lot of this comes down to composition. So we add an inherits on the material so that it is looking for edits from this class prim. We also add the renderer context, right, the target, and then this tab menu mask. And this is the secret sauce for filtering the tab menu to make it less insane to look at. So when you dive inside, we put just a standard surface down by default, right? And you can just go ahead and build your materials. Yeah, we'll call that good. All right, so this is how we have been building materials since the beginning in Solaris, right? When you have a material in your scene, sometimes people wonder, well, how do I edit that material? And in the simplest case, we won't get involved with instancing or anything like that, you can come over here to the scene graph tree, and we have added some tools to the right-click menu. So let's say we want to edit this look dev material. I can right-click on it and say, edit material properties. And that will put down this Swiss Army knife of a node that is edit material properties. It's a pretty powerful, albeit easily confusing tool because it's trying to do a lot of complicated things. But in this case, what it's done is it is pointing at our material and then it reads some metadata that we've started adding to our materials for the last release or two. Actually, starting in 20.5 especially, the interface. So if we look at our material, I'm going to hide the UI, go to metadata, and you'll notice this dialog script. And what it has done is it has dumped the dialog script string that was on the subnet. So this lets the edit material properties will recognize it and use that if it finds it. If it doesn't find it, what it does by default is it just alphabetically puts a parameter that corresponds to whatever inputs there are on the shader or the material that you've selected. So this lets you curate UIs to do nicer things. So here we are in our scene, and I want to change my material because we want it to be green. Green is so much better, right? I don't know if it's better, but it's different. So we've edited the material. In this case, remember I talked about the public interface. We are editing the public interface of our node, right? Because we went through and curated that. The way that you set up the public interface is, if we go back in here, you would use parameter VOPs, okay? So let's say we promote this subnet input for our color, and you'll see it here on the material. And then if we look at our new Karma materials metadata, it now has that dialog script. So this lets you, again, curate a UI. Why does this matter? How many lighters have ever tried to dig through like 1,000 nodes to find that one thing that's fiddling with the roughness because you got to turn it down because it's too hot in that shot? Yeah. So this lets the look dev artist curate this interface. At a previous place, they called them handles. It's like, here's the handles for the lighters. Here's the handles for effects. So that they had something that they could control without having to get into all of the guts and complexity of the shading network. It's as powerful for, again, related to composition reasons, but making your scene more efficient as well. But Chris, I want the whole spaghetti. I want all the noodles. I want it all. So we have Edit Material Network, and Edit Material Network does allow for that. This is an area that we've been doing some work in the last year or two to improve, to set the groundwork for improving this type of workflow. But what Edit Material Network does is you point it at a material, click load, and it will create VOPs to represent that shading graph. It's much better now than it has been in the past. There are still some cases where it trips up. Please don't hesitate to log bug reports. We're trying to polish this and fix things as we go, even though we're working towards being able to edit USD shade natively more directly. But in this case, I've got this whole network here. Let me make this bigger, okay? And I've gone through and I've started adding new nodes and I've started wiring things up. And in this case, what I did is I made a copy of these kind of texture nodes. I added a new image reader to override that little graphic that was showing up and wired that all in to the standard surface. So if we go back and look at our scene, I don't know if you noticed the graphic has changed. Liver peas, right? The composition magic. Oh, sorry, I should switch it. That was not switching. There we go. Right, so liver peas. Okay. And if I disable it, not only does the material go back, but if we look at our scene graph for the neutral material that we're editing, oh, that was an interesting glitch. So if you watch this here, you'll see it change because we started mutating the network. Because all of these edits that we're doing, they participate in composition. So we're just adding overrides. And even though in this case, we're not just setting values because shade inputs and outputs and node graph inputs and outputs are all connectable. So you're making connections. Those connections are still composable and get composed into the scene. Yes, in the back.
The edit material, does it create the graph on the fly from the USD stage, or how is it stored the representation of the node network?
Great question. So the question was, does the Edit Material Node Network live update the node representation of the material on the stage? It does not. So that is one of the tricky parts about it. Here, I'll put down just a new one just to illustrate that. So here we create a new node, we'll drag in, actually we'll do a simpler one just to be simple. You know what, we're gonna do default. That's really simple, okay? Look at that. And so right now if I dive inside, there's nothing in here. But if I click load, it'll cook, and then I've got my network in here. So it's an on-demand. That's part of the kind of clunkiness about it is it it's permanent. So if your material got updated, your VOPnet in the edit material network is not going to auto update.
If I load again, I may lose my change.
Yeah, loading again is one of those that, yeah, may or may not do reasonable things. So again, we're working towards making this better. I don't know when we'll see I don't know when we will be able to release it, or the ers and the ums that Bill has to. I'm just trying to help our awesome videographer have something to do. So I'm going to and ah and hum and ha, so he has to cut it out. We want this to be better. So keep logging RFEs, but the future hopefully isn't too far off of being able to edit these things more procedurally. Does that answer your question? Okay, awesome. Thank you. Thanks for asking. And again, please interrupt with any questions. As you can tell, I'm like super formal and I get thrown off really easily. But, all right. So now we know how to make materials. How do we bind them to stuff? How do we make those assignments? So as with Houdini and USD, right, there's a few different ways to do it. Ultimately, it's all using USD features, right, to bind. But we have a few different nodes in Solaris. So we're going to start off with the venerable assign material. And this is a straightforward node. You tell it the primitives you want to assign to, and you tell it the material that you want to bind them to, and it does it. And because we're on a machine with beefy hardware, we're going to start keeping Karma on, because it's beautiful. Ah, look at that. All right. Now, Vex, Mark gave some great caveats or info about Vex, when to use it, when to not. But if you need to do material assignments through Vex, there's a couple of things to keep in mind and to be aware of. The first is that although binding is a relationship, there is this little thing that has to be added called an API schema. So what is an API schema? An API schema is what you might call a decorator or a soft schema that can be applied to a primitive. So if we look at our shader ball and we look at its metadata, there is this API schemas list. You'll notice that there's this material binding API. Now, a few years ago, a few releases of USD ago, they became very strict. So Hydra does not care if there is a relationship on a prim or a relationship that says this is your material binding. The API schema must be present. This may have hit you in, I'm trying to remember if it was 19.5 or 19, somewhere around there. Because before, just adding material binding just worked. But because of reasons to make things better in the long run, Hydra is more strict about that, about API schemas being the way to do stuff like this in general. So in Vex, you can make this relationship using the set relationship target function, but you also need to apply the API schema. So if you need to do bindings in Vex, this is how to do it. Also, I forgot to mention at the beginning, but we'll put this HIP file up on the content library so that you can go through and look at it and refresh your memory later on. The next, this is, I would recommend if you can't use one of the LOP nodes, just use the Python API that USD ships with. And this is an example of how to do it. It takes care of the API schema being applied and all that jazz. The material linker, this is a nice UI that we've set up to try to make it simpler to do multiple bindings. So the way it works is you drag a material in here and it creates a card, and then you can drag from the viewport or from the geometry view over here into that to make the bindings. And I'm just going to delete that. And then finally, there's actually a way to, oh, my voice kind of cracked there almost. That was an accident too. Accidental voice cracks. All right. So there's actually a way to do material bindings through SOPs. So if you have the presence of this USD material path attribute, it will, or it can, excuse me, make material assignments. So on the SOP modify, it has the UI from SOP import, SOP create. There's this bind materials that's been there for a while. By default, it's set to do not bind materials. But you can tell it, hey, you know what? If you've got a material and you have this attribute, go ahead and make that assignment. That would be awfully convenient. And the LOP says, sure. And it goes ahead and makes that assignment. You can also create materials. And this will actually just create an empty container. Actually, we're going to do this just for fun. Metal gold new. Okay, so there is no metal gold new anywhere. And it says, hey, that material doesn't exist. You know what? I would like you to create that material. What? Wow. Now, it's not doing anything right now because it's just an empty material. So the celebration is a little subdued, but it's pretty cool. It's pretty cool.
I have a super silly question about why.
Oh, yes.
Sorry. Why the default is do not bind instead of bind according to an attribute?
Sorry, what was that?
Why the default is to not bind instead of bind according to the primitive attribute?
Oh, okay. So the question was why by default
default is to
we don't
not
bind, right,
instead of bind according to an attribute.
instead of binding
If
according to the
bind
attribute.
according to an attribute is not doing any damage. Is there any reason why the default is do not bind?
I think the reason was backwards compatibility because this came later. And so just to not all of a sudden start creating or adding materials, maybe unexpectedly or making bindings unexpectedly, we left it to do not bind by default. So that's a good question though. No, and it's a good observation. Like sometimes you'll notice that, like, why isn't this the new default? And we try hard to be backwards compatible as much as we can. There are some times where it's like, no, we're going to break it. Like again, the material builder kind of concept was a bit disruptive, but better in the long run, I think. But yeah, that's the reason why I think so.
Makes sense.
All right, now bindings, really quick. There is this thing in USD, we're not going to get into the details of it, called collection-based bindings. So up until this point, we've been talking about direct bindings, okay? But these collection-based bindings are different. They are different than what people often think, because a collection-based binding is not using a collection in the primitive pattern. A collection-based binding is a special type of binding in USD. And so if we look at our shader ball, instead of just this material binding relationship, you'll see these collections here. So this is a really awesome way to do bindings. We don't embrace it quite as much yet because we're waiting for a few more things to evolve and improve in USD itself. But it's a cool workflow where you could have this collection be the way that materials are assigned, which might reduce the amount of back and forth between, let's say, the modeling department and look dev. Because as long as modeling puts stuff into the right collection, it'll get the right material. So kind of a cool way to work. This should open the door to doing some bindings with instances a little bit easier, which is what we're really excited for. But we'll figure out better ways to present this and make it easier once those things in USD have sorted themselves out. All right, now we're gonna go back to the viewport. Pretty gold. And we're gonna talk about these cool aspects of binding materials in USD. So if anybody's ever expanded this folder in the material assign lab, you'll see all these curious looking things. Purpose, strength, what is this? I want purpose in my life, and I want strength. And our bindings do too, right? So what does this mean? What all of this means is that you can give bindings some extra attributes so that Hydra will say, you know what? You may think your material is this, but I've been told that it should be that. So in this case, what we've done is we've got this red material. And what I've done is I've set its strength to stronger than descendants. By default, materials in USD are weaker than descendants. So if we turn this off again, the shader ball has orange, but there are child prims, right? These neutral surfaces have their own material, and it's not, affecting them because they're by default just weaker than descendants. But if we do stronger than descendants, you can override the materials in your scene. There's a little caveat: native instances don't respect this quite like they should, but hopefully this has been fixed in USD and with Hydra 2, and we're hoping in the next release of Houdini, when we've got all that up and running, that this will just work with every primitive. Right now it'll work with everything but instanceable references. Just wanted to mention that as a little bit of a gotcha. Now, purpose. This is that other thing. What if I want to give different purposes to my materials? So here you can say this purpose is for just the preview render, which would be for GL. Oh, what? It's green. And I forgot to show because I forgot to do it, just to show you that it is working in Karma, right? So there's the override. But if I turn it to green, what? It's red. But Chris, its purpose was clear. But its purpose was clearly preview related, right? And Karma is not using preview materials or preview geometry. It's using full materials and render geometry. So if we wanted to override the render purpose, we would need to do that here by setting it to full render. So now we can turn off Karma, go back to the viewport, and it's still green. So this is a neat way to target materials for the render purpose. We've done this with geometry. The component builder helps you set this up. But if you're in a situation where you've got the same geometry needs to be shown regardless of the render delegate, but your full material has 50 gigs of textures and it's making the preview not very preview-like, you can use preview material instead. So this is really powerful. And again, the strength is awesome. The strength is great for when you need to debug something or you're trying to just override in a scene maybe for a specific render pass. But it's pretty powerful. This is really neat. Okay, any questions? Yes?
So would you recommend creating preview materials for, if we have heavier materials, for faster response of viewports?
Great question. So the question was, would you recommend making preview materials for faster performance in the viewport? Is that, okay, close enough, right? Yes, and something I failed to point out, if we go back in here, the material library by default has this auto-generate preview surface shaders. So the material library tries to do this for you. Now by default, it's just hooking up generic inputs. So it may or may not be more efficient. But that's the idea, is that it can give you this preview surface. The Houdini GL, Houdini VK uses Material X. The whole point of Material X is to be kind of universal, right? So if your Material X network is getting too big, right, then maybe you want to build a preview surface. But if you want the same look and the same everything in the same place, then just use Material X and keep that balance in mind, I guess. But yeah, you could do preview materials manually or by default.
Sorry, because I had another question.
Yeah.
You mentioned before that there were 3 types of prim types in the beginning you showed us: the material, the shader, and the node graph.
Mm-hmm.
How do you create the node graph? Where would that fit in?
So the node graph gets created the question was, we showed the 3 prim types, and how do you create a node graph? So the node graph gets created automatically from subnets. So if I were to put this in a subnet and go up, oops, hold on. Oh, sorry, I'm just gonna get rid of this. I think that's throwing it off. All right, I broke something. See, it happens to all of us. We're all in good company, right? It's a subnet, though. So we'll actually talk about the node graphs a little bit more in a second. Okay, bindings. We good on bindings? Okay. Now we're gonna get into the composition aspect of things. This is hopefully fun, hopefully interesting, and this is what excites me about USD materials. All right, so references. References are the R in liver peas, which, by the way, is soon to be still liver peas, but there's gonna be 2 R's because there's this new composition arc, relocates, that's slowly getting figured out in USD. But it'll look like liver peas. We'll just say liver peas now because that liver peas just doesn't work. So anyway, this is the R in liver peas currently, and that's referencing. So has anybody used quick materials in Houdini 20.5 or seen them or heard of it? A couple hands? Nice, okay. So what this is doing is it's using edit material properties to reference materials from disk. So we ship some materials with Houdini, but this quick service material in particular, just kind of an Uber shader with a lot of the important parameters promoted up to the public interface. And by default, that quick surface materials tool, it creates an edit material properties, but it also adds some spare params and folders to kind of hide and clean up the UI a little bit. But you can see here, it is referencing from this path in the Houdini installer. And Chris, why is this good? Who cares? So you've referenced your materials. Does it make you feel important? It does, because that rhymes. It does because that wasn't supposed to be a rhyme. It's supposed to be leading into a sentence. Because I can instance them, right? So I've made my scene more efficient. So no matter how many times this material exists in my scene, USD only has 1 copy of it because it's instanceable. What? Now, instanceable materials, you can't edit the children of the instance. We call those instance proxies, right? This is where those class the class editing comes into play, because you can indirectly edit the class of a material through those mechanisms. We've also made the material interface massive on this shader so that you should be able to get away with not having to edit the material network. Even for noises, we added that cool stuff with Copernicus. So you can click this button and it will just set up a little Copernicus network for you, and away you go. So you can do noises and textures this way if you would like. All right, so that's referencing. Oh, question in the back.
Can I reference a custom material?
The question was, can you reference a custom material? Yes. We don't even charge a licensing fee for referencing material. No, I'm kidding. Yeah, you can reference any material out of a USD file. So. And then promoting the parameters to the public interface. That is where you would set them up ahead of time with a parameter VOP so that they appear on the builder. That was this. Here, let me go back really quick and just, you know how I broke it? I will just make a new one. So when you come in here and promote subnet input is what you would do with these builders, because then it will show up here. If you do promote parameter, it'll still show up on the USD side, but this way it shows up on the builder itself. So you can just verify, or maybe you want to build like folders and conditions to hide and disable parameters.
And if I want something to be built in by default, like a texture, like the default base color, it would still remain in the material.
Yeah. So the question was, if I have a default texture? Yeah, you could do that. Let's see, I don't have a string here, but you would just set the default value on the parameter here. Yeah, no problem. That's a great question. So this is part of why we're showing it, because can I use my own materials? Yes, that's what the hope is that the takeaway is you can have your own catalog of materials and artists can reference them and efficiently reference them and edit that public interface without getting lost in the weeds of the shading network. So that's yes. Gold star, you get an A on the test. I don't wish there was a test, but kind of do. You know, if my kid's starting school, it's like, maybe we should do more tests. All right, we're not going to do that. Okay, node graphs. So there was a question earlier about creating node graphs, using node graphs, and we're going to talk about referencing node graphs. So this is part 2 of our part B of the referencing materials. So the way I create this, I'm going to show it before we get into it. Is down here I've got this little scene where I have been working on, actually, yeah, we'll just keep it on next view, where I've been working on flakes. And last minute, because I'm such a flake. All right. I appreciate the, you're making me feel at home, because my kids have learned to chuckle, like, oh, we just got to chuckle so dad'll be quiet. So thank you. So what I've done is I've built this little subnet for generating flakes. And we can see the result here, but I've added some UI to it, right? So I can adjust the density. Actually, I'm going to change the scale down so we can see our flakes a little bit easier, right? And the flakes, because it's for like kind of metallic car shader. So the flakes are, outputting a normal map. They're outputting a couple other signals so that I can use them to drive my material. But it's a subnet, right? Here's a working subnet. So it is this node graph. And this is, again, an example of doing things manually. We are aiming to make all of this easier and better and streamlined in the future. But I use a graphed branches to extract the node graph, and then I save it down to disk. And what do I do to use that, you might ask? So what you do is you come into your new material, and you would use a generic shader. And I have, this recipe will be with the files, but I added this recipe here for referencing node graphs. And the material library on a generic shader recognizes these spare parameters to, instead of translating a bunch of VOP nodes, which it's doing at the subnet, it just authors one prim and references it in. So we are going to grab our, oops. Oh no, how do I move this? There we go. I don't work on Windows a whole lot, and so I'm used to the Windows key, being able to move windows around on Linux and keep doing weird stuff. So, all right. So we have our, oops, let me save it out because it did not save. Okay. So if we come back to our generic shader and we find our node graph catalog, right? So we're going to reference it and click this button to tell it, you know what, I want my flakes. And if we look, nothing is happening right now because it's sitting off by itself. It doesn't have any parameters, but if you click import base parameters, it will read those parameters off of the node graph, all those inputs. So now I can do things like, oh, we're going to add in this mask here. What? This, and then you know what? Where's our normals? We're going to get that in here. There. So now we are well on our way to a killer car shader with metallic flakes, right? Does that make sense so far, what I just did? Okay, so we referenced the node graph and we're just reusing it. And we marked it as instanceable. So it's blue and efficient and friendly to our scene, right? So no matter how many shaders use our flake node graph, they're all going to be sharing prims and stuff. So this is an awesome workflow. I'm excited about us making this better and easier and more awesome in the future. But go ahead, do this now. Set it up for your pipelines and your workflows. This is a nice way to reuse work. All right, what else can we do with composition? So I mentioned indirect edits. We've just got a few minutes left, so we're gonna go fast. So in this scene, I've got a few different materials applied, but they all, and we're gonna talk about how this catalog was set up, but they all share some common ancestry. In the right-click menu for the scene graph tree, you'll notice there is this indirect editor nodes. And we called it indirect edits to try to help convey and simplify what's happening in USD. Because inherits and specializes, you might first go, well, specializes, well, I'm special. I specialize things, or I inherit things. I know what inheritance is. I can program. Yeah, I know what all that means. They don't mean quite those things, unfortunately. So anyway, this indirect editor nodes will identify when you've clicked on a prim that has inherits and specializes arcs. This will work for anything, but in the case of materials here, I can say, you know what, I would like to edit the quick materials class. And so this class location gets added to the scene, and because all these materials have this inherits arc looking at that location, they will look for overrides. So inherits does not behave like class inheritance. It really is like a overrides kind of a location. So when I opt in to start making edits, every material that is looking at that location will get those overrides. Now, if I were to change this to, say, the large box material, okay, the small box specializes from the large box, okay, so it shares that parent configuration. So only the boxes get it, because they are the only ones inheriting from, or looking at that location, inheriting from that location. Does that make sense? Kind of, yeah. Play with the file when you get it, and don't feel bad or like you're the only one in the world that is not getting this. It takes a while to sink in and to really, again, that word inherit is a little unfortunate because it's an override. And the inherit is the eye and liver piece. I forgot to mention that at the beginning. So it is the second strongest opinion type. The only thing more stronger in a composition sense are direct opinions that are being set on the prim itself. All right, last but not least. So building a material catalog, specializing. So specializes is the S in liver peas. And ironically, specializes behaves a little bit more like inheritance. You know, like in your programming, you've got this base class and you subclass it to make something more specialized. What? So the word does kind of make sense, but it also kind of is confusing. So specializes is the way that you would build up materials. So again, appreciate the chuckles. It's good. That's why Houdini users are great. So what I've got here is, I'm just going to copy this for fun, for the sake of the demo, okay? So we've got our metal one, Oops, let me get my display flag back here. Restart the render to make sure we're good. And we are good, great. So I've got metal 1 in my scene, and I want to specialize it. Because I don't just want metal 1, I want metal infinity, or whatever we're gonna call it. So before I do that, I'm gonna turn on the insertion point, this materials insertion point. What that'll do is all of the nodes that I create from the scene graph tree will just end up over here in the graph. So we'll keep things nice and organized. So if you right click on a material, you notice this doesn't show up on other primitives, but if you right click on a material, you'll see specialize new materials. So if we click that, it will create the Swiss Army knife of a node, the edit material properties, with the UI kind of organized and cleaned up a little bit. But it is creating an specializes from our metal 1. And by default, it's just called metal 1 specialized 1, because we had to come up with some default name, right? But we're gonna call this one metal gold. I like to kind of prefix, which is what you'll see over in the kind of example catalog, but I like to prefix the source in the name itself. So specializes can't come from disk. They have to be in that same scene graph, just like the way inherits work as well. But it has to be in that file. So there's no specializes from disk. If you were wondering why references can be in the scene or from disk, but specializes can't because USD just doesn't allow that. So what have we done? We've made a specialization of metal. So my gold is going to have a gold-like material, and on the fly, it's going to be Olympic. Wait, I can't say the O word. Olymp, something else, ick, right? Because we don't want to get in trouble with trademarks. All of the Olympics just ended, so I guess we're okay. But we have our Olympic gold. Wow, that's so great. Now, Chris, great, you made something gold. Why does this matter? Well, because we're specializing our metal, any edits in any context will just percolate through. Now, it's a little bit harder to show. We're not going to get into a really complex example right now because it'll end up chasing through the scene a little bit. But if we were to turn the metal list down on our base material, all the specializations, if they don't have their own stronger opinion, are going to reflect that change. Now here in this example, I'm only doing the material interface changes, but you could change the network itself as well. And again, those are the sorts of workflows that we are working hard to make better in future releases. So I'm not going to go through and do a ton of specializations, but this example over here, I've gone through and I've got, let me start over. I've got my gold here, copper, aluminum, silver, and nickel. And then I did another thing here where I specialized a specialized material. So in this case, I made anodized aluminum. And this anodized aluminum is a little bit different because it's, give me everything that aluminum's got, but you know what? Anodized aluminum, it's got this texture mat to kind of fiddle with the surface. It's a little anisotropic because anodization, somebody here knows how to say that word, I'm sure. That process that makes things anodized. Maybe it does something to the surface, and we want to, we want that to be reflected here. So this is the way you would kind of build up a catalog of materials. Specializes arc was added largely for materials workflows, or initially for materials workflows. There is in the HIP file, there's this little Python snippet that is a workaround for a bug that has been logged. So this bug, or at least we are 95% sure it's this bug, maybe a different bug, because composition can be fun to sort through. This bug basically is preventing the inheritance and the inherits overrides from working when you're passing through too many other composition arcs. So what this Python snippet does is it goes through and every material that has a specialization target, it goes, oh, what were your inherits? And then it just reauthors them. And then everything works like it will eventually. So when you're building a material catalog, this snippet should be the last thing that you add in there. And then the material catalog itself, you can write it out just with USD. Now, that was easy, right? Got a material catalog, boom. You can load that in the material linker, but we want thumbnails. So this is the live demo part because I didn't think to add this until the very end. There is a little Python snippet, which by the time, hopefully anybody's watching this or you've downloaded the file, we'll make sure that it works. But we're about to find out if it works. So what this post frame script is doing is it's using some Python tools to write out a catalog file with thumbnails. And let's see if this works.
You added a W just after the import OS.
Did I? Ooh, good catch. Cool. There we go. That looks more like it. So this is rendering out little thumbnails of all of the materials that it finds. And it will write out a DB file that has those thumbnails embedded, and it will point to your USD file. And then in the material linker, we can look at, point at our DB file, and we should get pretty thumbnails just like we do with the default catalog. The fact that there was only one typo, the W typo, thank you for catching that. That's like, awesome. Oh, yes, question.
Does it use like existing scene and geometry and camera to create thumbnails, or is it using like something pre-built, like shader wall and default camera?
Great question. So the question was, is it using, what scene is it using to generate the thumbnails, and is it using the default shader ball? Yes, it is. There are some ways to change that if you want to use a different scene, but by default it just grabs the one that we know is there because you have Houdini, so it'll just use that one. All right, moment of truth. Appreciate everybody's patience and let's see, opening the database file. Where did it go? Let's see. I might have messed up the path somewhere, which would be, oh, we were so close to victory, right? It should be that it just replaces the USD file. So it should be in there. Did I miss that? You know what? I must have messed something up. So, all right. It rendered thumbnails though, right? We saw thumbnails rendering. So something should have happened, but clearly I messed up the Python. I'll figure that out before we get the file up there. Again, a lot of the rough stuff, the manual stuff that you saw of building stuff with nodes, bless you. These things we are working to improve. We want to make this even better. You know, there's a lot of power in Solaris to edit and inspect and work with USD, but we want to make it even more powerful, even easier, without obfuscating or hiding the way USD is doing things. We're trying to find that balance because we know that if we start hiding too much USD, then we've just added a whole lot of complexity and foot guns and confusion. So appreciate your patience. Hopefully you took away some more details about how shading works in USD and how you can use composition to make your workflows and your pipelines better. Thank you. Sorry.